We all set? Question 8. Then, this is on the summer, whatever it is, 2013. The diagram shows the curves y equals a to the x and y equals 4b to the x. State the coordinates of the point of intersection of a to the x with the y-axis. Right, some of you are going to complain like mad about not getting the mark for this. But we need to read questions really carefully and pay attention to detail. State the coordinates of the point. Okay? That doesn't mean give the y value of the point where it crosses the y-axis. It means the coordinates. And so there is only one mark, so there's no grey area in this. The mark was for if x equals 0 on y equals a to the x, that's y equals a to the 0. Anything to the 0 is 1. So it's the point 0, 1. Y equals 1 is not enough, because the question said state the coordinates. State the coordinates, I'm going to highlight that again. State the coordinates of the point of intersection of y equals 4b to the x. Again, almost everybody knew what the answer was, but not everybody gave the right answer because it's coordinates. Where the other one intercepts the y-axis. If x is 0, 4 times b to the 0, 4 times 1 is 4. So this time it's the point 0, 4. And that was it. Right. State a possible value for A and a possible value for B. Right. There was one particular wrong answer here that loads of people made that really doesn't make an awful lot of sense. Which, to start with, I think we've established now that if that one crosses at 4 and that one crosses at 1, this is the one that is y equals a to the x, and this is the one that is y equals 4b to the x. Now, a to the x, that's the normal kind of shape that we recognise, isn't it? We on your poster you've got y equals 2 to the x and 3 to the x. And so we know that if a is a positive number greater than 1, then that's the shape of the graph. State a possible value for a, that's just give a number greater than 1. But remember that 1 to the power of x is always 1. 1 squared is 1, 1 cubed is 1, 1 to the 20 is 1. So if a equals 1, you just get a straight line that goes through 1. You get the line y equals 1. So a can't be 1, a must be bigger than 1. Any number bigger than 1, for part C, 2 would do the job. Anything greater than 1 is what they want in there. Now for the second one, this shape of curve, this is what we do if we have a 1 over, if we have an x to the, 2 to the minus x, for example, is one of the graphs that we've talked about as being that kind of shape. Okay, it's something to the minus power. Now if you think about, if we think that, that shape would be produced by doing, let's say, 2 to the minus x. Think about the graph 2 to the minus x. Now minus x means minus 1 times x, doesn't it? So we could write it like that, couldn't we? That means the same thing, because you multiply the powers, minus 1x gives us minus x. What's another way of writing 2 to the minus 1? A half. So the graph of 2 to the minus x, which looks like that kind of shape, is the same graph as the graph of a half to the x. In other words, whatever this number is, if it's something to the minus power, we could write the reciprocal of it to the power of positive x. So that means that b is a whole number, a number bigger than 1, with its reciprocal taken. Not necessarily a whole number, but a number bigger than 1 with its reciprocal. So that means possible value of b, if we take the reciprocal of a number bigger than 1, we get a number between 0 and 1. So a good suggestion for that would be to choose, that was A, b as being something like a half, or a third, or a quarter, or in fact anything between 0 and 1 as being our value for b. Okay. Not necessarily whole numbers, it didn't have to be integers as we do this. It didn't say that a and b were integers, but they're a number bigger than 1, and they're a number between 0 and 1. That's what we want. Right, that was 4 marks. The second half of the question, the next 5 marks, it's now given that ab equals 2, and we want to find the x-coordinate at the point of intersection of this. Well, if it's the point of intersection, that's when the y values are the same. So that's when a to the x equals 4b to the x. Okay, so there's our start point for part 2, and we're aiming for this expression down here. Now, think about this. Just look at where we're aiming for, because it's already a good idea to look at where you're going to. We want to have an answer that has log base 2 in it. So somewhere along the line, we want to work this out so we can have log base 2 in there. There are a couple of ways of doing this. The mark scheme has us taking logs very, very early. I actually did quite a lot of working out before I took logs when I did it. In fact, I'll do this 2 ways. I'll do this the way that I did it, the way that occurred to me, and the way that the mark scheme did it. Now, the mark scheme, if I remember correctly, started by taking log base 2 of both sides of this equation. And if we take log base 2, because we've got log base 2 in the answer, we get log base 2 of a to the x is log base 2 of 4b to the x. And we can now use our laws of logarithms. One of the laws of logarithms says that log base 2 of a to the x comes down to the front, doesn't it? This is x log base 2 of a. That seems like a smart move. Over here we've got to be really, really careful, because this power can only come down to the front if it's the power of all of that. Now this was only b to the x, it wasn't 4 to the x. So this line, this would be wrong. Okay, because that is not the same as that. It's not true to bring the x down to the front. Because that would imply that x was the power of 4b in brackets, and it's not. So that wouldn't be right. In fact, before we do that, we need to use another law of logarithms that says that this is 4 times b to the x. So this becomes log base 2 of 4 plus log base 2 of b to the x. On your poster of your logarithms, that's law 1, that's law 3. The subtraction one is law 2. Log base 2 of 4, remember that means what power of 2 gives you an answer of 4? That's equal to 2. Here we've got x log base 2 of b. Now our final answer is supposed to not have b in it. So we're going to have to use this statement now, which says that b is 2 over a, and let's work with that. So maybe now is a good time to replace b with 2 over a. See where we can go with this. And, well, shall we try and collect like terms together? Shall we do something with that now? We've got these 2 things involving x, so let's get them over onto the left-hand side. We've got x times log base 2 of a minus log base 2 of 2 over a equals 2. Where are we heading for? Okay. When we subtract logarithms, we divide these two terms. So here we've got a divided by 2 over a, so that's log base 2 of a squared over 2 equals 2. Do we follow that? That is, we've just done a divided by 2 over a, which means a times a over 2, which is a squared over 2. A little bit of work in there. We're really nearly there now, aren't we? So this is x equals 2 divided by log base 2 of a squared over 2. And we come to the very final step, which says x is 2 over log base 2 of a squared minus log base 2 of 2. Log base 2 of a squared is 2 log base 2 of a, and log base 2 of 2 is 1. And that's what we were heading for. It was quite tricky, and there was quite a bit of messing around with the logs to do there. I will just show you, because I did it a slightly different way. I'll just show you how I did it. I said that we've got started at the same point. A to the x is 4b to the x, which means a to the x is 4 brackets. I did my substitution straight away of replacing b with 2 over a, which gives me a to the x is 4 times 2 to the x over a to the x. And if I multiply everything by a to the x, I've got a to the 2x is 4 times 2 to the x. Now 4 is 2 squared. So I've got a to the 2x is equal to 2 to the 2 plus x. At which point I thought it might be nice to bring in my log base 2 now. So if I take log base 2 of both sides, I get log base 2 of a to the 2x equals 2 plus x. Because log base 2 of 2 to the 2 plus x is just 2 plus x. So 2x times log base 2 of a is 2 plus x. If I bring the x's over to the same side, I've got x brackets 2 log base 2 of a minus 1 equals 2. So x equals 2 over 2 log base 2 of a minus 1. And that was the way that I thought of doing it, which is more about treating it as an indices question and then doing logs at the last minute, whereas the other way of doing it is treating it as a logs question with a tiny little bit of manipulating indices as part of it. I think that's slightly neater, but it doesn't matter which way you do it. Okay? Are we happy with that? It was quite a kind of tough 5 marks, wasn't it? There was a lot of messing around just for those 5 marks. There we go. That's maths.